This question is worth a whopping 12 marks. There's no subparts, there's very minimal help given. So how are you supposed to do this? 12 marks. By the way, credits to Yishun Town Secondary School 2024 prelim paper. This appeared as a question in paper 2, question 10. So despite this carrying a lot of marks, 12 marks for this single question, these types of questions are not as rare as you may think. This usually happens in the last question, which in this case it did come as a last question, where you're just given a line and a curve, or sometimes it's a curve and a curve, and you are just asked to basically find the area of the shaded regions. So how are you supposed to do this? First things I want to clear, 12 marks doesn't mean you need 12 marks of thinking. Sometimes the reason why there's so many marks in this question is because of the fact that there are certain key points you need to bring out in order for the marker to give you the mark. So 12 marks, all it means is that there's 12 key points that the marker is looking for in your working when you do this question. Alright, so now that we've done this, how do we even start doing this? If this is the first time you've seen these types of questions, your mind might be overwhelmed because, of course, this is not the only thing they ask you to find. Let me read the question and summarize it essentially. So there's this curve, there's this line, there's P and Q are constants. A and B, which are the points here, are the stationary points of the curve. And they lie on the line as well. So essentially what they're saying is A and B, they are stationary points and are also points of intersection between the line and the curve. Alright? And one piece of information that they gave us is that at B, the x-coordinate of B is 2. So from this information only, we are supposed to find the total area of the shaded regions. So first of all, I noticed that we have to split this graph into two. One from here to here and one from here to here. So why is it the case? Now, first of all, I will let this point that's kind of in the middle, right, be another point called C. So I will just write this down. I will call this to be C. Why? Because if I, draw a dotted line downwards, you can see that it splits up the entire graph nicely. So I'm gonna do my working here. This is not going to be in the actual test paper. This is gonna be in the piece of paper that they gave for just rough work, right? And this is to help me understand what I need to find. Alright, so basically, this is my rough work. This is not my actual working. So what I'm gonna do is I would just go for it, right? What exactly does this question? So this is total area. So let's just try and find like a formula for the area so that I know what I need to find. So again, like I said, this splits the thing into two parts. So, and this is of finding the area under the curve, which means I need to make use of the integral. And it has to be between 2 points because the total area, which is a definite integral, right? So the first one is, what I will do is I will put an AX, the subscript X. This is just a notation. It's not an official one, but you can use things like this in your exam. Basically, I will just call AX the x coordinate of A. So by that logic, there will be an AY, but we don't need the AY because whenever we do integrals, we always are only concerned with the x coordinate unless the entire thing is rotated 90 degrees. But I will not get into that for now. So we are integrating from AX, then we have to move to the C, right? Because this is one portion of the graph. So CX. And then I won't use equations first. I will only use shapes. So basically what I have to do is I have to take the equation of take this weird looking shape. This like it is like a quadrant, right? If you can see, is this so I will take this, yeah, and then if you cannot visualize, this is the point where the line cuts through, and this will be the shaded part, the first shaded part. So I will take this, and then since I only want the shaded part, I will minus the trapezium, the unshaded part. So I will then minus the trapezium. So this is already one integral, and this is the only integral that we need, and of course it's in dx. This is the reason why we don't put this in our actual test paper, because the examiner will see this and be like, what do you mean? So this is just for visualization purposes. So we want to find the big quadrant minus the trapezium, and then we will get this black colored shaded part, right? So this is one integral only. Next, I will then plus the integral of, now I have to take care of this part. So now this is going from cx, the x coordinate of c, to this b, bx, again, the x coordinate of b. And now it seems to be like the trapezium. So we have to take this entire shape there, which is the trapezium. And if you cannot visualize it, the shaded part is here. So this is like this entire thing. Of course, it's not drawn to scale, but it's a good visualization. If it's drawn to scale, it will look more like this. It will look more like this, because as you can see, the height here is very small. So then the shaded part will be something like here. So this is the entire trapezium. Then I need to minus away the unshaded part to get the shaded part. So this will be like this weird looking shape here, and it's in terms of x. So this is essentially what I have to do. To find the area, I need to integrate firstly from ax to cx, meaning the x coordinate of a to the x coordinate of c. Then I have to minus this weird quadrant looking thing from the trapezium that is given by the unshaded part. Then this is only half of the answer because it is only up to here. Then I have to plus, now I have to integrate from cx to bx, x coordinate of c to x coordinate of b, which is here to here, of this trapezium, which includes the unshaded and the shaded part, and I have to minus away the unshaded part. So now that I have done this, how can we translate this into our equations that we know? So we know that this is just the equation of the curve, right? So in fact, I will write this down as the integral going from ax to cx, and this part is just the equation of the curve, because remember, when you're integrating a curve, what you're doing is finding the area underneath that curve until it reaches the x-axis. So here it will take the entire thing, shaded plus unshaded. So that is exactly what we want. So this will be the integral of the curve, which is x cubed plus px squared plus q. Then we have to minus away the trapezium, which you can already find the area of. But since we don't know what this c is, it is just best to integrate the equation of the line, so which is over here, this negative 2x plus 5. So we have to minus away, then we have this negative 2x plus 5 dx. So this is the first part of the area. Now I need to add this up to I need to add this. So this is again integral going from cx to bx. This is just this is a trapezium, right? So this is the unshaded plus shaded. But so in this case, we are just integrating the line. So this is negative 2x plus 5. Then we have to minus away this weird looking shape, which is given by the area under this curve from cx to bx, because it is the curve, as you can see, is going here, go down, is going down, which means that if we integrate it, we are finding the area underneath it, which means it is this weird shape. which is the equation of the curve. Okay, so now that we have this pretty long formula for the for the answer essentially, now we have to work backwards. How? Well, in this we see that we have some blanks, we have some unknowns that we need to find, right? First of all, we need to find the x coordinate of every single one of these points. Technically, we don't need to find bx. We already know what is bx. Bx is 2. So that's already one gone. Then we just need to find ax and cx, the x coordinate of point A and point C. Then we need to find our p and our q, the constants that make up the equation of the curve. So after we do that, then we can finally sub in everything here and get our final answer. So first of all, let me clean things up and we can actually start doing the question now. Okay, so in fact, I have written down the objectives for what we are supposed to do. We're supposed to find ax, cx, p, and q. So how do we start doing this? Well, it is given that in the question that A and B not only are the point of intersection, but are also stationary points, which means that if a point is a stationary point of a curve, that means that our dy dx equals to 0. So what we need to do firstly is we need to we need to differentiate this equation. So if we are given that y equals to x cubed plus px squared plus q, we have to dy dx. So dy dx, this using our power rule is just 3x cubed. Then from this, we can also use our power rule. This will give us 2px. Cool. So now we have only one unknown, which is the p. Why? Because q is a constant. If we differentiate a constant, it will become 0. So if we differentiate the equation of the curve, we just get this. Alright? So we know that when at p, right, is a stationary point. And furthermore, we know that the x coordinate of b, which is 2. So we can just substitute x equals to 2. So for example, so I will do this when x equals to 2, which is at there, dy dx equals to 0, which is correct because b is a stationary point. So we will end up getting 3 times 4 plus 4p equals to 0, because the dy dx is 0 and I'm just subbing into x equals to 2 into the right hand side. So we will end up getting p equals to -3. And we have actually done this. We have found our p. So once we have found our p, the natural thing to do is to find q. And in order for us to do that, first of all, we must then find the y coordinate of b. Why? Because it's a point of intersection between the curve and the line. So if b satisfies, so that means that actually b satisfies both this equation and this equation. So when x equals to 2, then I can find the y coordinate of b using the equation of the line, which is -2 times 2 plus 5, or 1. Which means that actually we can find the full coordinate of b, which is 2, 1. So because of this, we can then sub in our coordinates of b into this equation. Alright, so let me clean things up once again. Okay, so now I will just write down when x equals to 2, y equals to 1. So then I will then sub in these two solutions to this equation. So this will get 1 equals to 8 plus 4p plus q. And you might be thinking, well, we still have two unknowns, but don't forget, we already found our p earlier. So we can just sub into that. So that means that if we do it eventually, you will get q equals to 5. And you can kind of fact check this because the constant term of any polynomial equation, the graph, will always be the y-intercept. So in this case, it will be x cubed minus 3 because p is minus 3, minus 3x squared plus 5. So if you want to go ahead on like decimals or something and you plug this equation in, this a, the y coordinate of a will be 5, which is actually a way for you to determine the coordinate of the x coordinate of a. But that's not how I did it. You can try it. So q is therefore equals to 5. So now what we need to do is we need to find our a and b and c, most importantly. And actually we only need to find a and c because we already know the equation, the x coordinate of b. So how do we do this? Now we can use the method that I said before. We know that 5 is the y-intercept of this graph, the curve, sorry. How do you know this? Because when you sub in x equals to 0, you will just get 5, which is the point at A. So y coordinate of A is actually 5, which means that you can actually use the equation of the line since they intersect to find the coordinate of, to find the x coordinate of A, which now that I'm seeing it, you don't even need to do anything because it lies on the y-axis, so the x coordinate is 0. But okay, but here is a method to find both A and C at the same time. So what we need to do is, well, as usual, we can solve simultaneous equation. We can equate both equations since we are finding the points where the value of the x and the y are the same. So we equate both equations, so you'll get x cubed. Now I will replace the p and q with the ones that we found. So this will be minus 3x squared plus 5 equals to the equation of the line, minus 2 plus 5. So once we've done this, we realize that the 5 will cancel out, and then we shift the minus 2x to the other side, x cubed minus 3x squared plus 2x equals to 0. So once we are here, at a first glance you might think, this one have to use factor theorem, have to use long division, but no, you don't actually need to do that, because notice how every term has a common factor of x, which means that if you factor out an x, you will just get something times something equals to 0. Then we can just use our zero product rule, which states that if this times this equals to 0, then it's either this equals to 0 or the other thing equal to 0. So once this can just factorize, we get x minus 2, x minus 1 equals to 0, x equals to 2 or 1. We know that x equals to 2 is actually b because they are given. And we, from what I said just now, we know that x equals to 0 is our a, which means that x equals to 1 is our c. So in one shot, oh by the way, I forgot to update this, we already found q. So from one shot, we already know our ax and our cx. So by the way, this will be ax is our 0 and something, the y, let me put this y1. I don't care what y1 is because I don't need to use it in my calculation. Then next, our c is 1 y2. Again, I don't care what it is. So now that we've done this, we found everything we need to find, we can sub everything we found back into the equation for the area, and then we can get our answer. So let me clean things up again. Okay, so now let me rewrite the area formula again. But this time I won't even use the variable names. We are actually just going to plug in the answers. So this will be 0 to 1 because this is the first part. Then we have this quadrant looking thing, which is just this equation. So this will be x cubed minus 3x squared because p is negative 3. Then we have a plus 5 minus, then we have to minus the equation of the line because it will just be this trapezium. So this will be negative 2x plus 5, and then this will be a dx. This is the first part of the answer. Then we have plus integral going from c to b, cx to bx, which is 1 to 2, and then we have to first integrate the equation of the line. So this will be negative 2x plus 5. Then we have to minus away the equation of the curve because this is the line. Trapezium minus the weird looking shape is the shaded area. X cubed plus px squared plus q, everything dx. Now, you can simplify this. You can, start doing your integration now. This is just now, at this point, we have just reached to simple integration, definite integrals. But at the end, you will get 1 over 4 plus 1 over 4. This is 1 over 4. This is 1 over 4. And you will get 0.5 units square, which is an exact answer. And you are